Coterminal angles are two angles in standard position that share a terminal side. So if this is the side we're referring to, then we again always start from our x-axis. If we're going counterclockwise, that's going to be a positive angle measure. So to go up here, that's angle A. That would be positive. We could also go around this long way for angle B. That would be a negative angle. And stopping at this same side, we would say then that angle A and angle B would be coterminal angles. Also, reference angles, and this is very important. When we're setting up our, let me back up a little. When we're setting up our triangles, we want to make sure and pay attention to our reference angles, and we always want to use an acute angle measured from the x-axis to the terminal side. So I have two different examples here. Let's look at this first one. And again, remember we're going from the x-axis to the terminal side. So if we're looking at this point up here, negative 4, 3, and we have this side, we want to make a triangle out of this. And so here's the triangle we're looking at, and we know based on the points negative 4, 3 that this is negative 4, this is up 3, and then we're going from the x-axis to the terminal side. Here's our terminal side here, and so this is what we would refer to as our angle theta. That's going to be our reference angle when we set up this triangle. And our hypotenuse of 5, hypotenuse is always going to be positive. Alright, so as we're setting this up, we want to make sure and pay attention to that. So if we're talking about this particular triangle, we could then say here's our angle, so here's opposite, here's adjacent, here's hypotenuse. So then we would have our sine of theta is going to be, we're talking about, okay, so our sine of theta would be opposite over hypotenuse, and this is going to be equal to 3 over 5. That's a positive value. We're in quadrant 2, and that's giving us a positive value. Let's look at our cosine of theta. Cosine of theta, now we're going to use this negative value, negative 4, so it's a negative, adjacent over hypotenuse, 4/5. We're in quadrant 2, and our cosine value is negative. Let's look at this other example. Here we have a point at 12, negative 5. Again, we're going to make our triangle, and we're going from the x-axis to the terminal side. So here's our reference angle. Going from the x-axis to the terminal side, we know we're going 12 here, because we've gone 12 over, and we're going down 5. That's a negative 5. That makes our hypotenuse 13 using Pythagorean theorem. And so again, hypotenuse is always positive. Now let's look at our sine value here. Now we're in quadrant 4. So the sine of this angle, sine of theta, is going to, here's our opposite, and here's our hypotenuse. It's going to be negative 5/13. Whereas the cosine now is going to be, here's our adjacent side, positive 12/13. In quadrant 4, now we've got our cosine value where it's going to be a positive value. When we're setting up these triangles, always pay attention to what quadrant you are in. Remember, from the coordinate plane we have quadrants 1, 2, 3, and 4, and here both values are positive. Here when we go left and up, that means x is negative, y is positive. Here we're going left and down, both negative. Here right and down, so x is positive, y is negative. And our cosine values, those are our x values, that's the left and right. Sine values, that's our up and down. That's our positive is going up, negative is going down. So when we're paying attention to those quadrants, that's going to help us set these up and pay attention to whether these values should be positive or negative. Our sine values should be positive when we're in quadrants 1 and 2. Our cosine values are going to be positive when we're in quadrants 1 and 4. Again, sine values, this is when we're up, 1 and 2. Cosine values, this is when we're to the right, 1 and 4. Now tangent values, those are going to be positive when both sine and cosine have the same value. So for tangent, in quadrants 1 and 3 is where it's going to be positive. Now for sine to be negative, now we are going to the left. So, excuse me, we're going down, so that's going to be in quadrants 3 and 4. When we're talking about the cosine being negative, that's when we are going left. That's quadrants 2 and 3. And then for tangent, now this is when our sine and cosine have different values. All right, so for tangent, that's going to be quadrants 2 and 4. So make sure that as you set up your triangles, pay attention to what quadrant you are in, and then pay attention to the sine values. I'm talking about positive and negative. Pay attention to those values when you set that up. If we're asked to find the sine of 390 degrees, we're going to start here, and if we make a lap, now we're right back to here. There's 360, so here's the remaining 30. Really, all we need to think about with this is we can take away that 360 from our 390, and we'll think of this as the sine of 30 degrees. It doesn't make a difference how many laps we take. If we end up at this point, regardless of the number of laps, then our sine value is going to be the same there. So our sine would be equal to 1/2, regardless of how many laps we take. Now if our angle is given to us in radians, it's the same idea. We're going to take away 2 pi. So if I'm given something like this, 13 pi over 4, I'm going to take away 2 pi from that because that's 1 full lap. And so we would think of this as cosine of 5 pi over 4. So that's the value that we need to find. And then we would know that that's going to be equal to a negative square root of 2 over 2. So it doesn't make a difference how many laps we make around the circle. Where we end up is what makes the difference as far as finding those values.